the best marketing tagline in movie history might have been from the Ridley Scott film Alien. In space, no one can hear you scream. That phrase is true. And not only because of the distance from Earth, it has to do with how sound travels.
You don't have sound in space because sound requires molecules. You have to be able to move the molecules with the sound waves, and without the molecules there, the sound just doesn't move.
Space is silent because it's virtually empty. As few as 10 atoms in a cubic meter, compared to 10 trillion in our own atmosphere. And without that thick soup of atoms, sound just has no way to travel. But billions of years ago, it was a different story. Not long after the Big Bang, the entire universe was a ball of hot plasma, thick enough for sound to pass through. Shockwaves from the formation of the universe rippled through space, creating a cosmic rumble deeper than anything our ears could detect. What you're hearing now are those actual sounds, decoded by researchers and pitched up to something we humans can hear. These are the first sounds ever created. Primordial stirrings from a newborn universe. Today, space is a lot bigger, a lot emptier, and a lot quieter. But we should be grateful, because if sound did travel through space, we would all be bombarded by a constant deafening explosion. The roar of the sun. Every moment, our sun blares trillions of watts of sound energy through its turbulent surface. If it wasn't muted by the vacuum of space, that sound would be as loud as a jackhammer here on Earth. Luckily for us, we have the void of space to protect us. And we live in a world of amazing sonic diversity. The sandy deserts, the lush forests, the sound of the ocean, both on its surface and below. Our home planet is a rich soundscape because our ears are perfectly in tune with it. But our little island of sound isn't the only one. There are whole other worlds of sound out there, in the skies, the oceans, and the rocks of other planets, and far beyond.
What is sound? It's the vibrations of molecules in the air. It's a pressure wave. Sound takes on many forms, but the kind that we're most familiar with is pressure waves moving through gas.
Sound travels faster through lighter gases like helium,
making our voices sound higher pitched.
When the air is colder or made of heavier gases like sulfur hexafluoride,
sound travels more slowly.
But there's even more to it than that.
Sound can be transmitted through any kind of physical medium. So if you are in a swimming pool, you can still hear sound. That's being transmitted through water. Earthquakes are essentially sound waves being transmitted through the solid earth.
Our experience of sound here on Earth is only a sliver of what's possible. Each planet is a unique soundscape, shaped by its particular makeup. So let's go from planet to planet in our solar system to find out what the surface of each one would sound like to our ears. To be clear, you'd pretty much die instantly everywhere but here. But we're going to pretend to have superhuman powers that will keep us alive. So with that disclaimer out of the way, let's start closest to the sun.
Places like Mercury and these rocky bodies with no atmospheres would be similar to being in space. There would not be much sound, if any.
With its near-vacuum surface conditions, it might seem like Mercury would be completely devoid of sound. But it's there. Not in the air, but in the rocks. Scientists have found evidence that the planet is seismically active. So if you put your ear against the ground, you might catch the sound of something strange. A Mercury quake. Next up, Venus.
Because you have this really dense atmosphere, much denser than Earth's, the sound would tend toward what things sound like when you're underwater. If you could imagine something in between air and water, that kind of density, you're running your hand through that and you would feel that. If you were to just materialize in that environment of 900 degrees Fahrenheit and 100 times our atmospheric pressure, you would first be crushed, and then you would probably just burn up completely.
One thing we do know about Venus is that it has lightning. So you might hear thunder.
It turns out that Venus is one place we have real audio from. In the early 80s, the Soviet lander Venera 14 successfully landed on the surface. It survived for nearly an hour before shutting down. And during that time, it picked up these eerie sounds of the Venusian winds. But what about something more human? What would my voice sound like?
The denser atmosphere would tend to lower the pitch, but the hotter air would act to increase the speed of sound, making my voice sound higher. It's a strange scene to imagine. I'm on Venus, in this ethereal world that's a mix between a gas-like atmosphere and water. I'm almost floating. My voice, the thunder, it's all slightly muffled and distorted as it travels through the thick atmosphere.
Our next stop is a polar opposite sonic environment.
Sound on Mars is going to kind of be the opposite direction of Venus because the atmosphere on Mars is very, very thin compared to Earth's, and so there's just not very many molecules.
The wind speed can get very high as hurricane force at the surface sometimes. So imagine a 100-mile-per-hour wind on Earth, you'd be almost blown off your feet. If you were standing on the surface there in Mars, you'd feel it, but it would feel like a gentle breeze here on the surface of Earth.
You wouldn't necessarily hear the wind itself. You would hear the dust that's being picked up, and it would be banging against the faceplate of your spacesuit.
we wouldn't hear too much. Maybe if you were scuffling along on the surface, you could maybe very faintly hear that sound as you were clawing at the ground.
But Mars is another world where we don't have to rely purely on speculation. After sending robots for decades, we finally received the first real audio from the surface of Mars, recorded by the Perseverance rover in 2021. These are the sounds of the Martian winds and the clunk of the rover's wheels over the planet's surface. Sounds that our ancestors could have only dreamed of hearing. Wind and rocks are one thing, but what would our voices sound like? In this thin atmosphere, speech would sound quieter and wouldn't travel as far. And while the low-density air would usually make our voices sound higher, the colder temperatures would slow down the sound, and the pitch would balance out. The biggest change would come from the composition of the air. The atmosphere of Mars is mostly carbon dioxide, which absorbs high frequencies, so our voices would become muffled and distant. If our voices don't carry far, how about a piano? In the faint Martian air, it would sound like something you might hear in a dream. Let's continue on to the outer gas giants, starting with the biggest. Jupiter doesn't have a solid surface. The whole planet is made up of gas that gets denser and denser the deeper you go, eventually becoming a liquid. The pressure and temperature variations are what cause those beautiful swirling bands. Depending on where you were inside its layers, the soundscape would change drastically.
The interesting thing on Jupiter is that the pressure and the temperatures where the cloud decks are actually not so inhospitable. You have these super powerful lightning bolts. Where you'd hear echoes of echoes of echoes just back and forth.
So what about the rest of the outer planets? Like Jupiter, Saturn, Uranus, and Neptune are mostly made of hydrogen and helium. Those two gases are lighter than Earth's atmosphere, so our voices would generally sound higher pitched. But each layer of each planet would provide its own unique sonic experience. Different worlds of sound. From inside the raging storms of Saturn to the frigid methane clouds of Uranus.
To the murky depths of Neptune.
But what about our old friend Pluto?
It is probably the thinnest bound atmosphere that we know, but it also looks really complex. I mean, it's got layers. It's pretty different because the temperature is so low. Nitrogen is an ice. Carbon monoxide is mostly an ice. That's probably the weirdest, most different kind of place in terms of thinking about how composition, temperature, pressure would affect the sound.
There's one more world worth a listen. Not a planet, but a moon. Saturn's moon Titan is the only one we know of with a true atmosphere. It's even thicker than ours, but it's freezing cold and it rains liquid methane. In 2005, the Huygens space probe recorded audio as it descended through the thick atmosphere to the surface. What you're hearing is incredible. The sound of the winds from a tiny moon nearly 1 billion miles away. If you were standing on its surface, the soundscape might be eerily familiar. You might hear the sound of flowing liquid methane. Not a waterfall, but a methanofall. When you think of space, it's mostly space, where there's no medium to transmit sound. And yet, it's perfect for light. Light fills the universe, but sound doesn't.
The whole universe is connected by light. Light anywhere in the universe can travel to anywhere else in the universe. But with sound, you really are 1 trillion different islands of sound.
We think of Earth as special because it can support life. But it goes much further than that. It's one of the true places in the universe where sound is abundant. And all of that sound has impacted life on an evolutionary level.
If you look at life on Earth, being able to hear something seems to be a very big advantage, biologically, right? Because you can become aware of either predators or prey or food sources. So alien life in the universe would probably have an advantage to hear things also. In whatever planet or ocean or atmosphere they lived in.
These aliens would probably perceive sound in a totally different way. A way that's in tune with their own environment. And perhaps hear completely different frequencies. Sound as we understand it is so unbelievably rare. Yet, it's abundant right here, within this thin blanket of atmosphere. But if we travel straight up, it goes away very quickly. It gets quieter and quieter until it's gone.